once we decide on that boundary line, we now split just wait until you guys are done. I wouldn't want to interrupt your conversations. Once we have drawn that boundary line, we have split the coordinate grid into two sides. Half of the coordinate grid is where our answers live. Half of the coordinate grid are not answers to our question. How do we decide where the answers are? We take a test point. Now, since this line does not go through 0, 0, 0, 0 is a very easy point to use. 0 is an x, 0 is a y. I have this inequality. 2x plus 3y is less than or equal to 6. 0 plus 0. Is that less than 6? Yeah. So is 0, 0 a solution to this inequality? Yes. Which means every single point on this side of the line is a solution. All of them. And just to prove my point, see, 1, 2, 3. That point right there, 3, 3. Well, 3, that would be 6, plus 3 times 3 is 9. Oh, sorry, that's another 3. 6 plus 9 is 15. Is 15 less than 6? No. So we cannot color in that side of the line. Everybody got it? It's pretty easy, right? You make your boundary with the equality, and then you choose a checkpoint for the inequality. Now, sometimes some people like to say that less than means below the line is where you shade. And if this was greater than, we would have shaded on above the line. I don't like saying that too much in case your line looks like this. Please don't draw this. But if your line went like this, then below the line means over here, I would think. But then that's also to the right of the line, and some kids say, well, to the right is where greater than lives. Does everybody understand? That's why I always recommend using a test point, okay? Even if you think you know, just take a test. It's 1x and 1y, it's one substitution, and you can almost always check it in your head, okay? Everybody good? All right. Now, yesterday I lost time because we went over, ideally yesterday I wanted to finish this one with you and then have you do this one as your turn right when we finish. But the bell rang, so we took a little longer to go over the test than we had. So now we're at the point where it is your turn. So remember, I will remind you because we did this 24 hours ago. 1, set your boundary line. 2, a check for shading. 3, shade appropriately. And that's all for A. Once you have done all that, you can then visually, you will be able to see if B works. Okay? Go. Remember, your boundary is the line made by the equality, not by the inequality. Is 10 greater than or equal to 10? Yes. So is that a solution? Yes. It's on the line. So even though the line is the boundary, points on the line will all work. Everybody understand? And just easy to check, that point right there is 3, -1, right? 3 times 4 is 12. 2 times -1 is -2. 12 minus 2 is 10. Is 10 greater than or equal to 10? Yes. So all of these infinity of points will work. And so will every point in this shaded section. How far does this shaded section go? Infinitely to the right and infinitely up. And infinitely down. Everybody understand? So no matter what point I chose out here, it would work in this inequality. Is everybody good? That is the concept that inequalities bring. Everybody's okay? All right. Turn the page over because we're going to change things slightly. What is different about our first inequality? Anthony.
It can't be equal. It has to be greater.
It can't be equal. It can only be greater. So what does that tell us about the actual line? Let's go back. On this one, when I chose something from the actual line, I got 10 equaled 10.
So if it was the same case for just being greater than, that wouldn't work?
That won't work. Are the points on the line part of the solution? No. So let me remind you. Remember how if I just have one variable, and I'm not going to use x or y because that confuses the issue. If I had, for example, q is greater than or equal to 2, how would you graph that when I only had one variable? I'd start at 2. I'd go that way because the letter's first. And what would I do right at 2? I'd shade in the dot because 2 would work, right? What if 2 didn't work? I got to do an open dot, right? That tells me that 2.00001 works, but 2 doesn't. We all remember that, right? From grade 9 and from our review, correct? So we had to draw the boundary differently if it doesn't touch the boundary, right? Okay. So our boundary in an inequality has to be a line, doesn't it? Right? So we know that we have to set our boundary first. And how do we do that? We've just done it twice. How do we set our boundary here? What do we do to this inequality in order to set our boundary? Make it an equality. So I have 10x minus 5y equals 0. Now, what's the easiest way to make that graphable, of course? It's to put it in slope-intercept form, which is negative 5y equals negative 10x. Y equals 2x. Right? Everybody should be good there. That's grade 10. For some of you, that's grade 9. For some of you from other countries, that's grade 5. There's my graph, right? How do I put this on the graph? Starts at 0, 0, and what's my slope? Up 2, right 1, up 2, right 1, down 2, left 1, down 2, left 1. Agreed? Now, we know, you guys just explained it to me, that all of these dots won't work. And they won't, will they? Right? 0, 0. 0 minus 0. Is 0 greater than 0? No. So all of these actual dots won't work. Now, in old school, in grade 9, when we only had one variable, we had to do an open dot, yeah? So in order to do that here, I would have to make an infinity of open dots. Does that make sense? No, nobody can do that. So here's what we do here. Instead of drawing a solid line, we draw a dotted line. Now that tells me that all of my answers come right up to, but don't touch the line. Is everybody cool with that? Now, do you think anything else changes? Nope. All I got to do is shade. Now, this is a little bit weird, though. Check for shading. With what? What do we use? We usually use 0, 0. It's a test point, yeah? But I can't use 0, 0. Why? It's on the line, and we know the line doesn't work. So I have to choose another test point, yes? Does it matter which one? No. I always, one sec, Hayden. What did you say, actually? We'll do it that way. Negative 1, 1. That's cool. That would work because negative 1, 1 is well off the line, yes? I personally always like to stay on the axis. So one of the numbers is a 0. Everybody understand? Now, this says greater than, right? Now, we know in our previous two examples, the greater than and less than was above or below the line, right? But when it's leaned this way, what's above? This would be above, I would say. But then isn't this to the right? And right is greater and above is greater. So trying to memorize one line does this, one sign does that, I don't like doing that because I even screw it up sometimes. So I always use a test point. Now, Hayden wanted to use negative 1, 1. That's cool. Let's do that. That works. There's negative 1, 1. So I sub it in. 10 times negative 1, because the x was negative 1, minus 5 times positive 1 had to be greater than 0. What's 10 times negative 1? Negative 10 minus 5 is negative 15. Is negative 15 greater than 0? No. So is that in the solution set? No. So where is the solution? Over here. Now again, you could argue, is that below? All right, I don't know. And so memorizing that, this arrow means this arrow means that. I don't like doing that. Everybody cool? And then if you're ever in doubt, how easy is it to check? Very. Choose another point. This time, we'll choose one with a 0 in it. Everybody okay with that? That's 6, 0, right? So, 10 times 6 minus 5 times 0 is 60 greater than 0? Yeah. So this point is part of the solution, so I've shaded it correctly. Does everyone understand? It's not that complicated, right? I mean, it's pretty easy right now because all the lines are perfect. Yeah, there's no decimals, there's no fractions. It's pretty easy, right? Okay, well, let's try an easy one. You try this one on your own. There it is. Go. I'm going to go with crazy colors this time. What's step one always? Boundary line, right? Actually, I'm not going to talk through this because you guys may be working at your own pace. I'm just going to go ahead and start, okay? Oops. You can check your work against mine. Always nice to double check. Good? Everybody? Can all graph a line and figure out how to shade it? Going once. Going twice. Third and final.
So I did my points is 1 and -1. Because that would be on the line, right? So then
Positive 1.
as X and then -1.
-1, so right there.
Yeah, so then I did 5 times 1 and 5. Oh no. Yeah, I see.
Okay. We all good? Okay. What's different here? Now, the other class said this didn't print very well. This is the shaded side. They said it's hard to see on yours. So now we've got the graph we want to reverse engineer. Do you think anything changes? What did we deal with first? The other, when we had the equation. We dealt with the boundary first, right? So what should we do here? Right. So we're going to find the boundary. The boundary line. Now, is the boundary line an inequality or an equality? Equality. Now, Is this an easy boundary line to work with? I think so. Why? It's got an obvious y-intercept. Our y-intercept is what? 1. And what's our slope? 2/1. So what is our equality? Y equals 2x, 2/1 is 2, plus 1, right? Everyone agree? Now all I got to do is decide on whether this is greater than or less than, right? What was our next step when we were doing the other thing? We choose a test point, right? So what do you think our step should be here? Choose a test point. Is 0, 0 available to us? Yeah, because it's not on the line, right? So we can use 0, 0 as a test. Now, let's punch that in. 0 equals 2 times 0. Well, not equals, because we're going to decide on a greater than and less than here, correct? Plus 1. So now, 0 and 1. What sign do we put in there? 0 is less than 1, right? So what sign do we put in here? Y is less than 2x plus 1. Is it? Well, 0, 0 wasn't supposed to be one of our solutions. So is this the right sign here? What if you're confused? What should you do? Check with one that is in the solution zone, right? What would be a number or a point that is shaded in? You want to do negative 1, 1? Negative 1, 1 would work. Okay. So let's check. So negative 1, or 1 is the y, and then a blank because we're not sure. 2 times negative 1 plus 1, right? 1. What's 2 times negative 1? Negative 2 plus 1 is? Negative 1. Now how does the arrow point? This way, right? Which would give us y is greater than 2x plus 1. Which of those is correct? Which one of those is this graph? The red or the blue? The blue one. Everybody understand? So again, this is one of those things. I've used 0, 0 every time. When I suggested 0, 0, you were all like, yeah, let's use 0, 0. So we plugged it in, we got to here, and we got an inequality, correct? But if this was the inequality, then 0, 0 would have been part of the solution, right? Which means I would have shaded over here. But 0, 0 isn't part of the solution, so I had to shade over here, which is why it's this one. Is everybody cool? Jacob, you had your hand up at the beginning, then I did some explaining. Are you good now?
Are we always going to get to see the shaded side when we do this kind of question?
Yeah.
So when can we just do the opposite of what, you know what I mean?
Yes, you could, but that requires you to understand what's going on. And I've learned that a great many of you stop listening at what to do at the steps. You don't actually listen when I get into why something works. And here's an example of what I mean. 0. How do you graph on a single line that? So I got to put 2 on there, then what? Color it in, and then go to the right of it. All of you can do that in your sleep. But I give you this. How do you graph that one? I guarantee that most of you will do the same thing. That's what it really is. But most of you stop listening at, the arrow points right, so I'm going to graph into the right. This is, of course, the opposite of this, isn't it? Because that says 2 is greater than q, which means q is less than or equal to 2, doesn't it? So you got to go that way if it's the red one. That's what I'm concerned about when you try and pick up shortcuts on your own. Everybody cool? That's why I don't talk about this as hungry Pac-Men. That's why I say greater than and less than. Because if you read this, 2 is being eaten by q. I don't know. It doesn't make sense to me. But 2 is greater than q. Well, then obviously q is less than 2. Right? Okay. Your turn. Before you even start, this graph tells you a lot of stuff. Is it a greater than, less than, or greater than, equal to, less than, equal to? It's the equal to. I'm going to need this or this, right? Why? Solid line. And just to remind you, in case you can't see, this is the shaded side. So, in this case, is it okay to use 0, 0 when we do our test point? We could use anything on the line, but we can use 0, 0 because 0, 0 is part of our possible solutions, right? So 0, 0 will work this time. I don't have to even think about it. So let's go. First step is always the boundary. What do I know about that boundary line? Y-intercept is -2, and what's the slope? -2. So what's my line? I need to stop there for a moment. Is everybody good with that grade 10 stuff? Can you make a graph from an equation and take an equation to a graph? I just said the same thing twice. Can you take an equation to a graph and a graph to an equation? Everyone can do it? Okay, what part is bothering you? Do you understand that form? Okay, well, do you understand that that is the y-intercept? Well, there is the y-intercept. So it's -2. Do you understand that that is the slope, 2 minus 1? Rise of 2, run of -1. Slope is what's getting you. Then you need to see me after because you need to know what slope is. So everybody else is good here? All right. So now all I have to do is decide, because is that allowed? No. I need to have the right sign in there, correct? So I have y -2x minus 2. I'm going to choose a test point. I'm going to choose 0, 0 because it is in the solution area, the solution region, right? So I write in 0, -2 times 0 minus 2, 0 and -2. Where does the arrow go? 0 is greater than or equal to -2, right? So what goes here?
Technically should be not put the greater than or equal to because that's not. Should write on the bottom like the 0 is greater than or equal to -2 because it's not.
0 is greater than -2.
That's not equal to.
But it's greater than or equal to.
Oh, that would be true for a variable.
Oh, I see what you mean. Yeah, okay. Yeah. I understand what you're saying. Okay. Jacob is saying that really I only need that there. And then I have to remember that it's an equal to because it's a solid line there. Right? That's what he's saying. So then, what if I'm not sure? I don't believe myself. So what do? Try another point. Doesn't matter which point you try. I'm going to do 4, 0. What's -2 times 4? -8, right? What's negative 8 minus 2? So I would have negative 10 on the right, yes? And what's on the left? 0. Is 0 greater than negative 10? So are we correct? So this is our final answer. Everybody with me? Okay. Let's do a real life thing. It's a word problem. I know you all hate word problems, but you also need to know that they're actually super easy to solve. Okay? So, let's talk. Read the question. Tell me some stuff that the question tells you. I'm going to pause thinking, so somebody talk to me. Jacob. You know you have a max of 50, so whatever you do has to be what? Less than 1. You have a max of 50. Does that change? No. So 50 can't have any x's or y's, can it? So I know, and I'm going to do my equation over here in red, whatever I do has to be less than or equal to 50, right? Or what if I write it the other way? Could I write this? 50 is greater than or equal to. Is that okay? Okay. What else does the question tell me? I have two things that can change, can't I? Right? I can have aluminum. No, I'm too lazy. Al. Or I can have glass, correct? Since I have two things that can change, I have how many variables? 2. Who's in charge of what those variables are called? You are, right? So, what do you want to make aluminum? All right, so aluminum equals X. So that must make glass Y, correct? Is this 50 a quantity of either aluminum or glass? It's the money, right? So what am I really counting here? Actual amounts of aluminum and glass or the cost of aluminum and glass? Cost. So what does this X become? It is not X. What is it? No, 60X, because we made our, we made our aluminum X. So 1.75X plus what? 60Y has to be less than $50, right? Or I can't make the table. Yeah? Now, we could do this with just guess and check, couldn't we? If I bought 1 foot of aluminum, I could work out how much glass I could buy, yes? Right? I would just sub in, yeah? But if I write and use an inequality, I know all of my combinations right away, don't I? But there's a problem with that. What makes this barfy? Decimals. This isn't going to make a nice pretty line like the other ones, is it? Like if we start working it, okay, well that's not too bad. 60y equals negative 1.75x plus 50. Can I graph that yet? No. What do I got to do? Y equals negative 1.75x over 60 plus 50 over 60. Barf. Who wants to graph that? Not by hand. So what can we use? What have we already used this year that has graphed hideous stuff for us pretty easily? Our calculator. Now listen, I made a mistake last unit by letting you touch the calculators before I showed you how to do it. Because as soon as you people have a screen with buttons in front of you, because you're all crazy addicted to it. So you're just going to watch me. Then I'm going to let you try. Okay? Okay. Now, but first we're going to talk about why this is barfy. What makes it harder? Hayden already said it. It doesn't make a nice y equals mx plus b. It's not necessarily the decimals, is it? Right? Because if this was 1.5 over 60, that's 1/40th, right? Up 1 over 40. Easy peasy, yeah? It's not necessarily the decimals, but it's part of it. It's more important that we can't make a nice pretty line, yeah? All right, so what can we use to find an answer? We're going to use our graphing calculator. And we're going to do it the same way. But before I touch it, we're going to remind you of a few things. In a graphing calculator, when we push the button that takes us to the equations, the button says y equals, correct? Well, our original equation, what was wrong with that? Why can I not put that into my calculator? Y isn't isolated. So if we are going to use our graphing calculator, we must remember to manipulate our equation so y is isolated. So even though our calculator is going to make the graph for us, it can't do it unless we can do algebra. All right? So, just watch. I think it might already be entered into my calculator here. It is clear, but we'll do it now anyway. We've done our manipulation, yes? I've already updated iTunes, thank you. There is our manipulated equation, agreed? Okay, so I can enter it now, right? Wait. Negative 1.75 divided by 60, agreed? Then what would I push? The X button, right? Then what? Plus everyone agree? Okay, then I'm going to graph it. Now you can see I've set the window up differently, right? Why do I have no negatives there? Pardon? It's real life. Can I buy a negative amount of aluminum? Can I buy a negative amount of glass? No. So I don't need any negatives. Now I also know that my y-intercept is about 1, correct? And I know that my slope is negative. So I don't need very many y values, do I? Right? I could, if I wanted to, make my y maximum 1. Then the edge of the screen is a 1. Everybody cool? We're all good, yeah? That's our boundary line. Right? So now all we got to do is do the shading, correct? Well, we know that 50 is less than, right? So where would less than be? Here or here? I don't know. Let's check. Is 0, 0 a test point I can use? Is 0 less than 50? So if I bought no glass and no aluminum, have I spent under my $50? So that means this is part of it, correct? So I would shade under here, wouldn't I? Now watch this. See that right there, how it shows a line? If I go over to it, now it's flashing, I hit enter. Changes, now it's a thick line. I hit enter again. It's shading the upper right corner of a quadrant. Is that greater than or less than? Up and right. Greater. What's down and left? Watch. And it tells me where my solutions lie. Everybody cool? Now, the question is, what are the proportions I can buy? Right? How do I find that out from my calculator? Well, I know that I can't buy even 1 square meter of safety glass, can I? Because my glass was Y, right? What's the most safety glass I can buy? 5/6 of a meter, correct? But if I buy 5/6 of a meter, can I afford any aluminum? So I can't even buy 5/6, can I? Even though this is greater than, less than, or equal to, is that actual point allowed? Yes or no? No, because I have to buy some of each, don't I? So the most glass I can buy by our list. Wake up. Come on, you can do it. You can do it. There we go. Glass has to be, glass equals Y, and Y has to be less than 5/6 of a meter, yes? Because if I buy the full 5/6, I can't buy any aluminum. What about 0? Is 0 an option here? I have to make a table. So can I buy 0 glass? So where do my answers live for glass? What's the lowest amount I can buy? But I can't actually buy 0, so I write 0. 0 has to be less than our glass that we buy, which has to be less than 5/6. Even though it's a solid line. Does everybody understand? Because I have to buy a combo, right? So what is my X value then? I don't know, so I'm going to get my calculator to tell me. Isn't that an x-intercept that's a 0? So I got to calculate my 0, my left boundary. I got to get left to 0, which means my y's have to be positive, yes? Are my y's positive right now? So that's my left boundary. Now I need my right boundary, which is when my y's will be negative, right? Are my y's negative now? Yes? So I could buy 28.6 meters of aluminum. Yeah? Or no, aluminum was in feet, whatever it was, right? But can I actually buy 28.6? Because then I got no money, right? So what's my aluminum? 0 less than aluminum, less than 28.57. So 28.57. Everybody cool? Right? So now what does that tell us? Any amount of glass between 0 and 5/6 of a meter and any amount of aluminum between 0 and 28.57 will work. Everybody cool? And that's how you use these for real life problems. So, we're going to do one kind of together, kind of separate. If you want to use your calculator, you may go and get one. They're all back now, amazingly. I'd like to see them all back again afterwards. Or, is this possible to do with paper and pencil? Like, honestly, is it that hard? If I wanted to do this with paper and pencil, I know that the y-intercept is a little bit below 1, right? 5/6. And I know my slope goes down 2 and right, what was it? 60? So my slope is about 1/30th, right? So I could go down 1 and out 30 and be pretty close, wouldn't I? And then I could just sub in, right? Like 0, 0 would tell me I shade under here. And you know I can get pretty close to 30, right? So you could do it that way as well. Is everybody cool? I don't care which way you do, okay? If you want a calculator, go get one. I shouldn't have to collect your phones. It's getting a little down on me. But, do what you have to do. And then try this one before we go on. Now remember, what's that? That's y is less than, right? I'll change color. Which obviously means that's y is greater than, right? Okay. Now remember, y is first. Correct? That's when this works. So make sure when you're isolating, you keep y on the left. Because if you isolate with y on the right, then what happens to these signs? They got to change, just like this. Q is greater than 2. Letters on the left, so we just follow the arrow. Everybody cool? So you try and do this one. Go. Get a calculator if you want. This one's actually significantly easier to do with paper and pencil, if you wish. No, sit down. Now remember, I told you that it doesn't matter which you make x and y, right? But in this case, you can make your life real easy if you do this, for lack of a better word, the right way. What are you going to make tile? Yeah, tile should be x and stone should be y. Because 150, right? 2.5x plus 6y has to be less than or equal to 150, right? If you make that 6, then when you divide this, it works perfectly, right? So 6y has to be less than or equal to negative 2.5x plus 150. Y has to be less than negative 2.5 over 6x plus what? 25. And now it's pretty easy to do on paper, yeah? Because what is 2.5 divided by 6? Well, when you use your calculator, what do you get? It's a yucky number, yeah? Right? What makes this yucky? The decimal. Could I write it like this? Is that okay? Why? I just doubled them both, right? Now, can I graph that in my sleep on paper? Sure I can. Where would I start? If I was graphing this on paper, where could I start? The y-intercept would be 25, and I would go where? Down 5, right? So how many 5s can I go down before I get to 0? 5 of them, which means I'm going to have to do 5 runs, right? What's 5 times 12? So isn't it going to come out to 60? And there's my line. Where do I shade? Under. Because if I spend no money, I'm less than my max, right? So now all we got to do is use our brains to figure out what the combinations are. Can I buy those 2 points? Why not, Jacob? Yes, if I buy one of those limits, I can't buy the other one, right? So, what's the lowest amount of stone I can buy? 0, but I can't buy 0 stone to a maximum of what? 25, but I can't buy 25 or I've spent my whole budget. What's the lowest amount of tile I can buy? 0, but I can't buy 0 to a maximum of 60. And any X and Y that are between those, I'm okay. But, let me ask you this. Is this okay? 30 and 29. Why not? Because 29 is outside of my range. Right? Would this be okay? Yeah. Would this be okay? No. Everybody cool? So I know we've talked about domain and range a lot, but we haven't really applied it to anything. But here is how we apply it. Everybody cool? Now you will notice I have conveniently decided that I am going to finish off these lessons with all the key points in one spot. So, what does a linear inequality describe? What is a linear? We've just done 10 of them. What did it give us? Tell me anything about a linear inequality. I'll take anything right now. What does it do? Anything that we have just spent 2 days working on. Excellent. A linear inequality describes a split of the coordinate plane. Great. That's something it describes. Good. There, now we're getting warm. Pardon me? Well, that's the boundary, right? A linear inequality describes, 1, a boundary line, and what does that boundary line do? Splits our grid into 2 regions. Right? One of those regions does what? All points in one of the regions does what? Do what? They work with the equation. They work with the inequality. Now, when I say work, what does that actually mean we have done with those values? We've subbed them in, right? All points in one region work with the inequality. So that is our solution region. All the points that work. Why is that important? We use that for our shading. The related linear equality gives us the boundary line. And what else does that boundary line tell us? What do we use for shading? How do we know where to shade? Test points. So that boundary line gives us where we've got to choose between our test points, right? The related linear inequality gives us the boundary line, which allows us to choose our test points. I put test points just in case you want to check a second one, right? And what's the line? Solid. If it's solid, what is the symbols we're working with? Right, these ones. Or it's broken or dotted or whatever you want to say, and that's when we're dealing with these. And then I have a typo here. We're. How do I know where? Test point. What do I like to use if it's available? 0, 0. Right? If it's not available, I like to use an intercept, right? 0, y, or x, 0. One of those three. Then I sub it in. If it works, I shade. I shade over it. If it doesn't, I shade the other side. Everybody cool? All right, you've got the rest of the period to work. Now listen to me. If you are happy with C's and C pluses, the work I have circled on page 134 and 135 is what you need to be able to do. Do you need to be able to do all of them? No, because if you can do one or two of them, you can probably do all of them. You only want a C or a C plus, by all means, only do practice from page 134. If you want to get the B or the A, you'd better do a couple from page 135. Okay? Do as much, he said hopefully, or as little, he said knowingly, as you wish. Few people picked up on that joke. Thank you. Go.